Hello everyone, I'm Wei Senkai, the presenter for presenting the paper with title Engagement Estimation for an e-learning environment application. This is my profile and I'm the PhD candidate for Japan Advanced Institute of Science and Technology. I graduated from University of Information Technology in Myanmar 2017 and I achieved my master's degree in 2020 September this year. From JICE, I belong to the School of Information Science. I'm interested in doing the deep learning research that is focused on the computer vision field. Currently, I'm doing the research project that is related with human emotion. As for my previous experiences, I did an internship about 4 months at a company in Myanmar as a junior software engineer. I also joined the laboratory that collaborated with my undergraduate university. And I published 2 papers, including the one that I present for today, and the other one is in the SIC International Conference. This is the agenda for today's presentations. Firstly, I would like to introduce my research, and after that, I would like to present my proposed methodologies and show the result after that. And finally, I would like to conclude my presentations. This day, we interact with the virtual assistants by using the powers of internet speed, especially during pandemic period. Nearly all the systems are converted to the virtual assistant in order to avoid the interactions with people in this day. An online learning system is one of the kind of these applications and becoming a significance in conducting the lessons in these pandemic situations. In the online learning system, the student engagement is very important. A statistic shows how much students are interested in the lectures. And according to the lessons, the percentage of students who are dropping out from their online lectures is between 20% and 60%. This is because students feel bored during the lectures and cannot keep up with the lectures. Therefore, it is important to keep the good communications with students in order to prevent them from dropping out the lectures. If the students feel bored or is not interested in the lectures, they look away from what the lecturer is speaking or doing something that is unrelated with lectures. In the physical classroom, experienced lecturers knows that students are not interested in the lectures by analyzing their facial expressions or behaviors. In that situation, students can adjust the situations by, not the student, lecturers can adjust the situations by telling the funny story to draw the student attention back to the lectures. However, in the virtual classroom, lecturers cannot be able to detect the student engagement status because there is no interaction with students. From the student point of view, watching the recorded lectures is boring for them, especially they are watching at home or at the comfortable spotlight in bed. From the lecturer's point of view, they don't know whether the students are interested or not. This kind of difficulties encourage us to perform the automatic engagement estimation system based on the facial expressions that was captured by the cameras. Our purpose is to encourage the virtual learning systems by overcoming their difficulties and prevent the student from dropping out from their lectures by recognizing the engagement levels. In order to achieve this purpose, we propose the automated engagement recognition system based on the analysis of the facial expressions. According to the previous researchers, Mayers designs their models based on the deep convolutional neural network in order to recognize the facial expressions. One of the advantages of their methods is their models can express the special features that are important for facial expressions recognitions. Their method is depend on the amount of data, and if there is insufficient data, it leads to overfitting problem. Similar to Mayer's model, James also constructs the models based on the deep neural network. Unlike the previous model that I mentioned earlier, and they use the residual block to prevent the gradients vanishing problems around the deep network. And they also need a huge amount of data for model training. The third author found that the performance of the convolutional neural network is dependent on the level data, and therefore they use the Siamese and triplets network architectures in order to learn the unfamiliar features. Their models provide more generalizations. However, in their methods, they manually select apex and onset frame. According to the author he, they use two different networks for recognizing emotions. One is the binary classification model for classifying the given inputs are belonging to the positive or negative emotions. By using the binary classification result, they use the scans model that is trained for target emotions. Their limitation is poor recognition on less amount of data. According to the researchers Chen, they use the deep neural network and support vector machines for facial expression recognition and avoid the overfitting problems. However, their model is not end-to-end mode. This is the flowchart of our proposed model. Firstly, we feed the input frames to VGG16's model that is already pre-trained for face recognition. The reasons for adopting the VGG16's model is they achieve the 98% accuracy in face recognition. That means VGG16's model can capture the important features like the significant features for nose, mouth, or something like this for face recognition. VGG16 models give the extracted features as the features match from fully connected layers, that is called FC6 and FC7. In order to determine features from which layers have more generalized information, we use the S field at the end. However, the features from the VG16 models are used for face recognition, not for facial expression recognition. Therefore, we use the DBND features, that is deep peak natural difference, to get the features that is useful for facial expression recognition. We classify the input features into peak and natural frames by considering the individual differences, because different people expresses their facial expressions for a single affected state in different way, and we perform the classifications. We utilize the dataset DAISCE dataset for affected state in the E environment, and this is the video dataset including 112 different participants who are watching the lectures video, and their faces are captured with front camera. And each video have 4 affected states that are abundant, confused, engagement, and confusions. And each affected state has 4 levels starting from 0 to 3. 0 means very low level, 1 means low levels, 2 is high, and 3 is very high levels. As for the preprocessing, we convert the videos into frames by using the FF embed, and randomly select the 0.005% of the original dataset. Since we intend to fit the input frames into the VGG16 model, we did the same preprocessing that of the VGG16 model. This is the training result that I obtained for FC6 layers. We can see the accuracy is around 50% in recognition. This is for FC7 layers, and accuracy is less than from the ones from the FC6 layers, and therefore we select the features from FC6. This is the result for clustering the peak and natural frames for the single persons. We use k-means clustering because k-means clustering works well in the case of known numbers of clusters. And red circles indicates the centers of each cluster, and black circles is one of the samples from each cluster. This is the visualizations of the samples in cluster 0. This is for samples in cluster 1. Normally in the beginning of the class, students are enthusiastic about the lectures and show their interest. However, as the letters continue, they feel bored and their affective state towards the letters is changed. And if we compare the eyes of each person in the image, the top image, his eyes is looking towards to the centers of the screens and seems like he is interested in the letters. In the bottom image, although he is still looking at the screen, his posture seems like he feels bored and shows his state, and so cluster zeros might be the group of the peak frame. This is the result for different passes. Red and dark blue circles represents the centers of the centers of each cluster, and black means samples. Greens and yellows are for cluster zeros, and blues and pink are for cluster 1. This is the visualization of the samples in cluster 0. This is for the cluster 1. If we compare the eye in the bottom, in the left-sided image seems like he is looking towards the cameras and listening to the letters. He shows his interest by focusing his eyes on the screen. In the right-sided image, his eyes is looking away from the camera, and it means that he is not interested. In order to include my presentations, we propose the automated recognitions for engagement levels based on the facial expressions features in our study. Since different people shows the different facial expressions for a particular state, we also consider the individual differences in this study. Our result is still needs to make an improvement in accuracies, and therefore we plan to increase our recognition rate in the future. This is the end of my presentations. Thank you very much for attending my presentation sessions.